Greetings, another special request, this time AS Physics Mechanics projectile motion. They like this in questions because it brings in an awful lot of different bits of your physics topic. Vectors, equations of motion, the SUVAT stuff, Newton's 3 laws of motion, free fall, objects falling because of gravity, and even potential energy and kinetic energy may come into this. Trick with projectile motion, you're talking about projectiles, things that have been shot, flung, thrown, or projected, which is where the word comes from, sideways, and then will still be falling under gravity as they're travelling sideways. If you have a ball and just let go of it, it falls downwards at an accelerating rate, at an accelerating velocity. If you send it sideways, it doesn't just travel sideways, it also accelerates downwards. So you end up with a motion like this. It's the way that what happens when you throw a ball, it's what happens when you throw it, when you fire a gun, project an arrow, whatever. So you get a motion like this. And the trick here is you can separate out the two velocity vectors. You will have a constant sideways velocity or horizontal velocity, but you will have a vertical velocity which is changing because of gravity. So treat that as constant, treat that as accelerating. So that's the trick, just split it into two. Now, first question that you've been given is about a tennis ball being hit, and it is being recorded on a film. The images are being taken every 5 milliseconds, so that's 5.0 times 10 to the minus 3 seconds between each of these pictures of the tennis ball, right? And you can see here from the distances that it's accelerating between A and D, but between D and G you're allowed to consider it as going at constant velocity. We've also been given the distance between those 2 points. Now, the first bit of the question is actually, in my opinion, very easy. They've said its velocity is 0 at A, it reaches constant velocity at D as it leaves the racket, and it travels a horizontal distance of 0.68 meters between there and there. Show that the horizontal velocity is about 45 meters a second. Well, this is not difficult because they've told you that there's 5 milliseconds between each of those places. So between D and E, 5 milliseconds, and between E and F, 5 milliseconds, and between F and G, 5 milliseconds. Add up the times and you get that it's 15 milliseconds between D and G. So you have a total time of 15 milliseconds, a total distance of 0.68 meters. So it's simply going to be that velocity is going to be distance divided by time, or as we're using SUVAT, we'll call it S over T. S is 0.68 meters. T is 15 milliseconds. So beware. 15, I'll write it as times 10 to the minus 3 seconds. That, when you calculate it, comes out as 45.3 recurring meters per second. Again, they've asked you to show that it's 45, so when you work out your answer, put some decimal places, and if you like, then you can round it off to 2SF as 45, or leave it as 45.3 for now for them. So you've shown that you know how to get that answer. Now, second bit, calculate the horizontal acceleration. Right, again, delightfully, you've just worked out that the thing at D is doing 45, call it 45.3 meters per second. You know that at A it was 0 meters per second. So in the SUVAT equations, that's U, that's V. And they've asked you to work out the acceleration. Well, general terms. Acceleration is going to be final velocity minus initial velocity divided by time interval. And in this, again, it's 1, 2, 3 intervals between photographs, so it's 15 milliseconds again. So we get v minus u delta t, call it 45.3, because u is 0, v is 45.3, so the change is 45.3. The time interval is the 15 times 10 to the minus 3 seconds again, and when you work that lot out, it comes to 3022 meters per second squared. Go along with what we've got, sort of two significant figures, which would mean it comes out as 3,000 meters per second. Don't forget, 0 it counts as a significant figure as well, so that's fine. 3,000 meters per second. Now, next bit is where they're telling us, now this is back to that stuff I mentioned right back at the start, that you can consider horizontal velocity and vertical velocity, which I have inexplicably labelled as horizontal as well. That's vertical velocity and horizontal velocity can be considered independent of each other. They said it's been projected horizontally and it started off at a height of 2.3 meters above level ground. Show the ball would fall to the ground in 0.7 seconds. So here we've got movement, but it's movement under gravity. So the thing is travelling horizontally but falling at the same time. You've just got to work out how long it takes it to fall 2.3 meters. The vertical velocity has nothing to do with this. All you've got to worry about is the acceleration due to gravity. Call it 9.81 meters per second squared. Pick out a Suvat equation that does the job. You know distance, and you can use S equals ut, you know time, they've told you, plus AT squared. Another thing is here that u is 0, so this simplifies to just being S equals AT squared. Okay. Sorry, that's AT squared over 2, it's half AT squared, so S equals AT squared over 2. Right, S equals ut plus half AT squared. Write it like that to make it easier. And we simplified that because u equals 0. So we can rearrange in this and get ourselves that t squared equals 2s over a, and acceleration is going to be g, so it's going to be 9.81 meters per second squared because it's accelerating downwards. You can rearrange this further and say that time is going to be the square root of 2 multiplied by the distance, 2.3 meters, divide by the acceleration, which I'll put in as 9.81, and that gives you an answer of 0.685 seconds, which rounds nicely to their 0.7. Again, make sure you show your decimals. Don't just write 0.7 because they'll just assume that you've just said, oh, there's the answer, there you go. So that's the sort of thing they're after. And then again, this is the separating horizontals and verticals. Calculate the horizontal distance the ball will travel. Right, we know back from here that it's travelling at 45.3 meters a second horizontally. We know from this calculation that it's going to be in the air for 0.685 seconds. So this lot here was horizontal movement, and then horizontal, and then using the vertical to work out the time. So that was u vertical is 0. In this one, we're looking at horizontal distance. So I'm going to say here v horizontal is then 45.3 recurring meters per second, and I've got a time now of 0.685 seconds. Dead easy stuff, this. This is going to be distance is velocity multiplied by time. So multiply those together and you end up with about 31.0 meters, right? And that works out fine, right? So you've now got a distance travelled, which is how far your ball would have managed to go horizontally. So so if you'd sort of sketch that as a little diagram, the ball would have travelled in a path like this, right? It would have travelled 2.3 meters down, and it would have travelled 31 meters across. Now, they've then said, why wouldn't the ball actually travel the whole 31 meters? Well, it's a tennis ball. It's quite big. It's fairly lightweight. It's got, its surface area compared to its mass is pretty big. So it's going to be affected by air resistance. And what the air resistance does is that it causes forces on the ball, and that decelerates. So it's got deceleration, right, and then reducing the horizontal. So the horizontal speed reduces because of air resistance. That's what gets you your 2 marks.